Alright. Wait a minute. Okay. Let me see. Okay. Let's continue. Okay, if I remember correctly, we already done the chapter 5 homework simulation. Where is it? We already done this. Fog.py. Like this. In the CPU, fog.py. Here it is. I mean, where? If I remember correctly, it is something like this. We get the action and we get the process tree, something like that. And I'm kind of curious about the generator. This tool generator.py allows the user to create little C programs that exercise fog in different ways, so as to gain better understanding of how fog works. A sample usage is just as follows. Okay. Like this. Random seed. Okay, random. Alright. Ini okay, this is the initialize line, I guess. Init runnable. We get a macro. Time get second. Okay. Okay, read the Dobro to read.c run.c. What is the difference between read.c and run.c? Number of action default 10, fork change default 30. This one weight change. Okay. Oh, not randomize. Okay, the default negative one. But you will see when you run this is a randomly generated C program. In this case, you will see something like this. Okay. Alright. So if the RC is less than 0, you will get an error. Okay. The first part from the top up to the beginning of main will be included in every generated C program. The piece of code with ortay and fork ortay are just simple wrappers to the wait and fork system calls, and either succeed as they usually will, or detect an error by checking the written code stored in RC. Okay, it looks like RC stands for return code, and exit via the assert, right? If the return code or the RC less than 0, you will exit with the assert call. The wrappers are useful when it's okay to simply exit upon failure, which it is here but not always, and make the code in main easier to read. Aside, assert. If you not only read it, is a macro that simply checks the truth of the expression you pass to it. Is assert a macro though? The assertion is true. Assert simply returns and the program continues. If it is false, the process will exit. You know what? Let me try this first. Oh wait, we are generating that. Hold on a minute. This is read. And then what about run? So what is the difference between read and run? I mean, can we like run the read.c code? Or do we need to both of it is not executable? Like what? I'm not sure about the read one. Line 9. Wait, what? Wait, time. Oh, right. Wait, did I'm trying to execute the wait, did I'm trying to execute the source code. I thought it was binary. So let's compile that. Something like this. Oh, okay. No such file or directory. Oh, interesting. Run.c. Hold on a minute. Well, let me just generate again, I guess. Okay. Wait, did JS mode remove that? That should not be the case, right? So what happened? Oh, right. Okay. Because I misplaced the order. The file run.c is gone. Okay, anyway. Looks like I'm still not fully awake. Okay. Oh, okay. Oh, sorry, not that one. I think this one. interesting. Wait, how many? Okay. Like this one. Again, and then fog. Okay. Okay. What is this mean? Is this mean fog? Let me try to understand this. Okay, fog. Alright. And then fog again. Wait. Record. Okay. Mark. Okay. Head. Okay, assert. Okay, PID. Next is there is a Goldberg variable. Oh no. The Goldberg variable had changed to n. Wait, and then fog. Interesting. Is this symbol mean record? Or maybe wait. Mean the arrow to the right. I'm assuming this is fog. Representation or something like that. But what about the arrow to the left? Okay. And then inside of C, that process, we fog D, okay, record. Okay. Maybe the arrow to the left is representation for record. Maybe. Okay, wait and okay. Record. Wait again. Oh. Let me try to understand this. We allocate some memory. Okay, check if the allocation fail or not, and then move to PID, this one, okay, and then copy the name from the jar, do we change the head at some point? I mean, the default is null, right? So maybe the next is null, and then we change the head to n. Maybe something like that. So at the head, maybe okay, maybe in this one is no. Yeah, maybe something like linked list. The head is null, something like that. So I'm assuming record make the process as, what is it called? As the head of the process, something like that. But yeah, if n if this is n in here means that that n in here means that we already killed the process of C. Maybe, and then we fork E, okay, with A. Let me see the readme. Okay, the process will exit. The interesting part of the code is changed with different random seed is found in main. Here we see the main process, which we will refer to as process A or just A for short. Okay, start, call for or die to create another process and then wait for that to complete. Calling this one wait or die. The third process could be just sleep for some period of time, here for second, and then exits. Okay, exit. So maybe the negative here means we already exit from the child process. A challenge for you then is to predict what the output will look like when this program runs. As usual, we can get the result simply by using this C flag. Okay. Compute here, right? wait, is this the result? So what we run here is the result. Is that it? Interesting. What is it called again? Okay. Hello, welcome. Later. Interesting. The operating system programming is more of a design or implementation difficulty. I'm not sure. I just learned about the operating system development, and we are currently still on the chapter 5 of the book. It is called Operating System 3 Easy Pieces. But if I assume is it design or implementation difficulty, maybe both, maybe both of it is difficult. I'm still not sure. But yeah, some software or some program usually hard to design. If a difficulty having a good design, I guess. But yeah, it can be both. Designing a good operating system can be difficult, and then implement those design can also be difficult. But again, I'm still not sure. The way to read the output is as follows. Okay, it is the output. The way to read the output is as follows. The first column shows the time when certain event takes place. In this case, there are two events that happen at time 0. First process A start running, okay. A plus, right. This one start running. Then A Fox and grid B, okay, this is the symbol, the arrow to the right. B start running and immediately sleep for 6 seconds. Oh, okay. As shown in the code. When this sleep is done, B prints that it has been created. Okay. But it doesn't do much. In fact, it just exits. Right, I think this one. Okay, so in the B minus representation, when the B process exit at time 6, oh, okay, so we at least know that the 6 or the time measurement is seconds. Okay. In the output, however, in reality, we know that B plus happened just before B minus. Okay. Finally, once B has exit, the wait or die calls in its parent process. A returns, then A finally prints out take place. Okay, once P has exit, the wait or die calls in its parent process A returns, and then a final printout takes place to indicate this has happened. Oh. So is the symbol arrow to the left in here means that we are giving the control back from B to A? Is that it? Maybe. So this, the arrow to the right, like this one, means that we give the control from the parent, which is C, to the process, and then the running something, and when the exit, right? Oh, okay, negative T, and this is negative B. Okay. Oh, maybe something like that. Yeah, I'm not sure. Are they supposed to be a row? I think this is supposed to be a row. Okay, so T give control back to C, and then C exit, and then C give control back to A. Maybe something like that. A number of flags control the randomly generated code that gets created. They are okay. You can check the source code for the flag, right? There are also a few flags that control which C file get created for the code. Okay, readable. This is the file shown to you and optimized for readability. Okay. Can we run the readable file? I don't think so. I guess this is the file that will be compiled and run. It is identical to the above but adds print statement and such. I'm kind of curious. Can we compile this? Oh, at least we can compile that. Right, let's see. Okay. Snip sync. Okay, and then exit. Okay. Sleep for 8 seconds, sleep for 10, and then exit. Okay. Asset more than 0. Okay. Asset RC more than 0. Okay. Then exit. Or die, fall, sleep, and then exit. Okay. Yeah, I mean, this one can be simplified to something like this. If we run this, right, nothing will get print because there is no print statement in here. But we have STTI. Interesting. Wait, there is no output. Okay. Finally, there is one other flag. There's A that lets you specify a program exactly. Okay, the action list, if I assume correctly. Where is it? Okay, this one. Action list. Oh, default none. Okay. Instead of randomly generated one, okay. So instead generated a random action, we specify the action itself. Alright. Process A. Wait a minute. Let me check. Okay, it's okay, when we start the main function, it is the process A, I'm assuming. And then we start another process, then it becomes process B. Okay, wait, okay. This comment creates the default process, which then creates B, which sleeps for 1 second but doesn't do anything else. In the meanwhile, A then waits for B to complete. Okay. More complex example can be created. Wait. Okay, interesting. Not that one. For P, and then what is this mean? One, wait, okay. Oh, is it the child process? Process A create to process B and C, okay. Oh, this is the first process, this is the second process, I assume. And then waits for both. For both, okay. Wait a minute. For B, okay. First process. Oh. Okay, maybe the one inside the curly bracket is the instruction for the child process. Maybe. So this is what happened in the B process. B foxy, and then B fox D, and then wait for C and D, and then this one wait for P, I assume. Process A creates P and then wait for it to complete, and then P creates C and D, right? And waits for them to complete. Again, from this one, fork C, and then process 2, fork D, which is process 2 is the P process. And then we wait. Process 3 wait, something like this. Yeah, I'm not sure about this one. Is this process 3? Read through into the homework question to gain the full understanding of folk. Okay. Coding homework. Coding homeworks are small exercise where you write code to run on a real machine to get some experience with some basic operating system API. After all, you are probably a computer scientist and therefore should like to code, right? Should like to code. Okay. If you don't, there is always computer science theory, but that's pretty hard. Okay. Of course, to truly become an expert, you have to spend more than a little time hacking away at the machine. Indeed, find every excuse you can to write some code and see how it works. Every excuse to write some code. Spend the time and become the wise master you know you can be. Okay. Is there basic open source code to study? I taught game development from scratch and a lot of open source library had example code. Does this apply to operating system too? You can check the Linux kernel source code, I guess. Linux. If you want to check about the kernel. This one, let me copy this in the chat. Or wait, I cannot forget. Wait a minute. No, not that one. I think I put some list in the GitHub that you can check. For example, this one, simple operating system, I guess. You can check this one too. Let me copy the list in the chat. Again, I wish there is a such functionality to the list, but yeah, looks like it's not a priority for GitHub yet. You can check this one. I'm not sure if this is related to the operating system. So yeah. There is even the TTY implementation. Oh, sorry, display manager, right? But yeah, maybe you can start out from this, especially this one, I think. And if I remember correctly, where is it? Maybe in preface. We will be taking a look at this one. Okay. The second type is based on a real operating system kernel XV6. This project are great for students that already have some C and want to get their hands dirty inside the operating system. Yeah, maybe this one, the XV6 that the book talking about. I haven't tried this yet, but maybe I will check this out later on. Oh, if you state some, I will check it. Thanks. Okay, you're welcome. Hello Luigi, welcome. How are you, bro? Fortunately, still the same. Nothing really changed that much. And currently, we are checking out chapter 5 in the homework section. The homework code. I'm assuming we will be writing some code for the homework. Oh, we also check out the, what is it called? The generator to generate the C source code, I guess. Where is it? Something like this. And we can run that like this. So this will give some, what is it called? Some simulation, maybe that's the word. The simulation about what is going on. For example, we spawn the parent process. It is called A. And then A fork B, and then we start the B process, and then we exit the B process, and then we give the control back from B to A. You know, this arrow but to the left instead of the right. That's what I assume it means. This arrow, the one to the right, can means that we give the control to B. So A process or process A give control to the B process, and then we run the B process, and then after the B process exit, we are, what is it called? We give the control back from the B process to the A process, and then again we fork C, right? We fork C, we give control to C process, we run this instruction, and then after the C exit, we give the control back to A, and so on. So yeah, it's kind of interesting to see. In this homework, you are to gain some familiarity with the process management APIs about which you just read. Okay, don't worry. It's even more fun than it sounds. Okay. You'll in general be much better off if you find as much time as you can to write some code. So why not start now? Right. Okay. Write a program that calls fork. Okay, before calling fork, have the main process access a variable, okay, example x, and set its value to something. 100, okay. What value is the variable in the chat process? Oh, what value is the variable in the chat process? What happens to the variable when both the child and parent change the value of x? Okay, this is interesting. I kind of forgot GTP debug child process. Maybe something like that. Okay. Maybe we will take a look at this to see what's going on, I guess. Let me copy this in the chat. In case anyone wants to take a look. On most systems, GTP has no special support for debugging programs, which create additional process using the fork function. When the program fork, again, no special support for debugging program which create additional process using fork function. When a program fork, GTP will continue to debug the parent process, right? And the chat process will run unimpeded. If you have set a breakpoint in any code with the child, then execute, the chat will get a type signal which, unless it gets the signal, will cause it to terminate. Okay, so that is why when previously I tried to set the breakpoint, where is it? In this one, the exec VP with GTP, let me set the flag, right? I can add the level, but I think this is enough. GTP and then okay, chapter 5, P4, and then okay, something like this. When we check with GTP, right, and using the breakpoint exec VP, something like this, and run, we didn't stop at this line or this function because it is in the child process, not in the parent process. Again, GTP will continue to debug the parent process, right? So that is why maybe we have something like this, the detaching after a fork from that process. So yeah, that's what I'm curious about previously. Okay. However, if you want to debug the chat process, there is a workaround which isn't too painful. Okay. Put a call to sleep in the code which the chat process execute. After the fork, it may be useful to sleep only if a certain environment variable is set or a certain file exists, so that the delay need not occur when you don't want to run GTP on the child. While the child is sleeping, use the PS program to get its process ID, then tell GTP a new invocation of GTP. Oh, a new invocation of GTP if you are also debugging the parent process. To attach to the chat process, okay. Attach. Let me check. That's process ID. Okay. From that point on, you can debug the chat process just like any other process. On some systems, GTP provides support for debugging programs that creates additional process using the fork or vfork function. On GNU/Linux platform, this feature is supported with kernel version 2.5.46 and later. The fork debugging commands are supported in native mode and when connected to GTP server in either target remote or target extended remote mode. By default, when a program forks, GTP will continue to debug the parent process and the child process will run unimpeded. If you want to follow the child process instead of the parent process, use the command set follow fork mode. Oh, so if we just want to follow the child process instead of the parent process, we can set follow fork mode. Okay. Set the debugger response to a program call of fork or vfork. A call to fork or vfork creates a new process. The mode argument can be parent. The original process is debugged after a fork. The chat process runs unimpeded. This is the default. Okay. Child. The new process is debugged after a fork. The parent process runs unimpeded. So you display the current debugger response to a fork or vfork call. Let me try. Okay, what is it called? GTP chapter P4. So, not that one. follow fork. Oh, there is follow exec mode and follow fork mode. Interesting. Is same. Is there a help? No. Okay. But yeah, this is kind of interesting. Follow exec mode. I'm assuming this is for the exec system call, like exec VP. I'm assuming. And then there's also fork mode. So fork mode. Debugger respond to a program call of fork is parent. Okay. On Linux, if you want to debug both the parent and child process, use the command set detach on fork. Okay, tell GTP whether to detach one of the process after a fork or retain debugger control over them both. On, okay, the child process or parent process, depending on the value of follow fork mode, will be detached and allowed to run independently. This is the default. Oh, okay, wait. That's why there is this detaching after fork from child process. And this is the PID or the process identifier for the child process, I assume. So we are detaching the parent or the child. Will be detached and allowed to run independently. Okay, so I assume because follow fork mode is the parent, right? The follow, what is it called? Follow fork mode is the parent. We are detaching the child process and run independently. Okay, both process will be held under control of GTP. One process, child or parent, depending on the value of follow fork mode, is debugged as usual, while the other is held suspend. Oh, while the other is held suspend. Held suspend. Okay. I mean, I am still not sure which one is suspend, In this documentation said that depends on the value of follow fork mode. So if the value follow fork mode is, let's say, parent, which one will be suspend? Is it the parent that gets suspend? For example, something like, where is it? Not that one. Something like this, right? The follow fork mode in the current GTP is parent, so is the parent gonna have suspend? Let me try. First thing first, the test on fork on. We'll just touch the child of a fork is on. Okay. Set off P, something like that. Break exec VP. Okay. Wait. Okay. Looks like the one that had suspend is the parent process, I assume. If the follow fork mode is parent, I mean, yeah, we are suspend right now. Exit. Okay, this is the parent process, this is the child process. Interesting. Well, you know what, let's try doing the homework. Write a program that calls fork. Before calling fork, if the main process access a variable. Wait. But yet, we can write anything, right? Let me check again. So that's on fork off run. Okay. So that's on fork. Oh, okay. Sorry, it's not visual but set. Okay, and then that's on fork. Then GTP will retain control of all fork process, including nested forks. You can nest the fork process under the control of GTP by using the inferiors command. Why is it called inferiors? I'm not sure. Inferiors command and switch from one fork to another by using the inferior command. Oh, interesting. Okay, let me check. Inferiors. No, okay. Talk with debugging one of the fork process. So what happened in here? If you ask to debug a chat process, okay. Let me change this. Follow fork mode. Parent, okay. Set to type. And again we set the detach on fork off, if I remember correctly, okay. Now let's run that out. Attaching after thread, okay. New inferior. Oh, no stack. Hold on a minute. Are we in the chat process? Or the parent process? Inferior 3 exit normally, okay. Insufficient debug info. Wait, what? Oh. Okay. Let me check. Info inferior, right? Okay. I think we are already executing this one. If I understand correctly. Executing new program, okay. We already exit this normally. With debugging. That's from it. Okay. That's inferior. Or ID, okay. Maybe 3. It's not running, okay. Maybe 2. Okay. That's. Okay. Become null. So we are going back to this one. The parent process, I assume. Let's try kill. Oh, program is not being run. I need to run, allowing it to run independently. Kill it using kill inferior command. Okay, second maybe it's not running. Oh, maybe kill. But when we try to kill, the program is not being run. That is interesting. Inferior 1. Oh, okay. The asterisk. Where is it? This asterisk symbol means that GTP currently on this process, I assume, which is already finished running, right? Because it is null other than this one, showing the PID, process ID. Okay, interesting. If we kill, okay, we stop the process. Okay, interesting. If you ask to debug a chat process and a vfork is followed by an exec, okay, exec system call, GTP execute the new target up to the first breakpoint in the new target. If you have a breakpoint set on main in your original program, the breakpoint will also be set on the chat process main. Okay, interesting. In your original program, the breakpoint will also be set on the chat process main. Okay. On some system, when a chat process is spawned by vfork, you cannot debug the chat or parent until exec call completes. Until an exec call complete. After an exec call execute, the new target restart. Okay. By default, after an exec call execute, GTP discard the symbol of the previous executable image. Can change behavior with I think we will try this out on the next section with a combination of this instruction, to check what the value of the variable in the chat process. Okay, so I think that's it for now. Thank you for watching and see you next time. Bye bye.